Next problem, area enclosed by plane curve using polar coordinates. Okay, first we are going to find using a double integral the area of cardioid r equal to a of 1 plus cos theta. So this is the question. Now we don't know the integrals, right? It is a double integral, but we don't know anything. We have only r. R is a radius, a into 1 plus cos theta only we know, and it is a cardioid. They have mentioned the type of the image. So first I am going to draw the image. Okay, usually this will be your x and this will be your y, right? So here we are going to use our theta because it is in the cos theta sin theta form. So this side is going to be your theta and this is also your theta. This theta is your 0 and this theta is your pi. So the line is from pi to 0, 0 to pi. Okay, so this point is theta equal to pi by 2, the half of the pi. Okay, the entire line is a pi and it is the half. Here also theta equal to pi by 2. So the half of the pi, right? Now what is this? It is a cardioid. So we have to draw the shape of a heart because it is a cardioid. Done. Okay, that's all. So we got all this. Now we had only the radius r equal to a plus or equal to a into 1 plus cos theta. Okay, so this curve, okay, that means the radius is from the 0 point to here. So this is your r equal to a into 1 plus cos theta. So this is your radius. I am going to mark this point as O and this point as P. Okay, that's all. Now we are going to find the area enclosed by the plane curves. Okay, what is the area we are going to find? We are going to find the region, this, the entire region. Okay, so this is the region we are going to find. Okay, now we are going to write the integrals. Okay, so area required. How you will write the integral? First thing is there is two part. This is first and second. We have two shapes, the part 1 and the second part. So we have to find for both the part. We can find this part and we will calculate it for twice so that we will get both the part, right? For that purpose, I am going to write it as 2 times the integral of, what is your theta? Your theta is from 0 to pi, right? Your theta is from 0 to the line pi, and one more integral is r. The radius is from r equal to, this point is what? This point is 0 point, right? Your r equal to 0 to the point here. Which one? The radius r equal to a into 1 plus cos theta. Okay, and the term r, we know it is an r dr d theta. Okay, that's all. We got the integrals. Now we can directly do the integration. We got the integrals and intervals, so we can do the integral. Equal to 2 times integral of 0 to pi. This one is r square. Why it is r square? I am going to integrate this r. Okay, with respect to our dr. Dr means we have r. So the r will become, usually we have x. If we integrate with respect to dx, what will happen? It will become x square by 2, right? Similarly, for we have r, we are going to integrate with respect to r. So it will become r square by 2. So the integral limits are r equal to a into 1 plus cos theta, and the lower limit is r equal to 0, and we have d theta there. Now I am going to apply the upper limit and lower limit. What is the upper limit? A plus, I am sorry, a into 1 plus cos theta the whole square by 2, and the lower limit is 0. So we can write 0 into d theta. Okay. So we have, I am going to take 2 integral 0 to pi. Here we can write a square 1 plus cos theta the whole square by 2 into d theta. So I am going to take this a and this 2 outside. So it will become 2a square by 2 integral 0 to pi. These 2's will get cancelled, and the remaining term we have is 1 plus cos theta the whole square, which is in the form of a plus b the whole square, right? It is in the form of a plus b the whole square. So that a square integral 0 to pi, I am going to write it as 1 plus cos square theta plus 2 cos theta, which is 2ab into d theta, equal to a square integral 0 to pi. We are going to integrate this. So 1 plus, we can write our cos square theta into 1 plus cos 2 theta by 2. Okay, this cos square theta is replaced as 1 plus cos 2 theta by 2, and we have this cos 2 cos theta into d theta. Okay, again I am going to take this 2 outside. So a square by 2 integral 0 to pi so we have 2 only here, but we don't have here, but we have commonly taken the 2 outside. So here also we want to include the 2. What happened here? If it is 1 into 2 into 2, so the upper limit, sorry, the numerator will become 2 plus 1 plus cos 2 theta plus here also we will do into 2. Then it will become 4 cos theta into d theta equal to a square by 2 integral 0 to pi. What happens this? 3 plus cos 2 theta plus 4 cos theta d theta equal to a square by 2. I am going to integrate this with respect to theta now. So here in 3 we don't have any theta, so we will include a theta for an integration. Okay, plus what is the next one? Here we have cos 2 theta. So cos 2 theta will become as, if we integrate with respect to theta, it will become sin 2 theta by 2 plus what happened to this? This will become 4 cos theta is sin theta. So the integral is 0 to pi. Okay, for theta we are going to replace 0 to pi. So a square by 2, your 3 into pi. So 3 into pi plus sine 2 into pi by 2 plus 4 sine pi. Okay. minus this is 0. So 3 into 0 plus sine 2 into 0 by 2 plus 4 sine into 0. What happens next? So we should know that 3 pi, this is 3 pi, sine 2 pi. What is the value of sine 2 pi? So this 2's will, so the value of sine pi is 0. So we can put 0, and the value of sine pi again is 0, and this is 0, this is also 0 and 0. So the remaining terms we have 3 by 2 a square. So this is the pi also, square unit. So this is the area, the required area. That's all. And similarly we have one more problem. So let us finish this now.